Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 6, Rewriting one trig function in terms of another, Example 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In this problem, we want to rewrite tangent of x in terms of secant of x. In other words, we want to end with something that looks like tangent of x equals some function of secant of x. So how can we do that? Well, same way we did the previous problems where there was a specific value involved. We found a trig identity that connects the function we're starting with and the function we want it in terms of. Do you know almost gave it away. Do you know a trig identity that connects tangent and secant? You should. It's a Pythagorean identity. Let's start with tangent squared of x plus 1 is equal to secant squared of x. And remember, our goal is to make this say tangent of x. So what do we have to do first to start isolating the tangent? Subtracting 1 is a good idea. That will get us closer to our goal of tangent of x equals. Right now it says tangent squared of x equals. Now on the right side we have secant squared of x minus 1. And since we don't know what secant squared of x equals, the best we could do is write secant squared of x minus 1. How do we get rid of the square on the tangent? And the answer is square root both sides of the equation. So square root the left and square root the right. And the purpose of that was to cancel the square on the tangent. But what do we do on the right side? Well, two things, one you can do and one you can't do. Number one, when you square root both sides of an equation, you have to use a plus minus. The exception would be if there was more information in the problem about a specific quadrant we were looking in. For example, if we were looking in quadrant 2 and new tangent had to come out negative, then we would put the negative in front of the square root. But in the absence of any information that narrows it down to one quadrant, we use plus minus for algebraic reasons. The second thing is what you can't do, and what you can't do is split the square root up. There's a temptation, whenever you see a square root over an addition or subtraction problem, to split it up into two square roots. In this case, the square root of secant squared x minus the square root of 1. The problem is you can never split up a square root across a plus or a minus. So what can we do with that square root? Well, in short, nothing. We're stuck with it. So as simplifiable as it may look, this is actually as far as we can take the problem. And now we have tangent in terms of secant. Again, without further information about the quadrant, we need the plus minus. If we had quadrant information, then we could decide whether or not tangent was positive or negative.